I'm going to show you how to design a truss in MD Solid. So first thing you want to do is go ahead and open the program. You're going to want to click on the trusses category and then new truss. The spacing and the grid you're going to have to set up. I typically set it up to be 10 spaces by 10 spaces. Just makes it symmetrical for you. The first thing you're going to want to do is create the members. And so I'm going to click and drag a member clear across here, right like that. A common problem that people have with MD Solids is they want to make their system so that it will add a member in. Like let's say they wanted to draw a line down here. They want to add a joint right there. That's not how this works. You have to draw the individual members first. So I'm going to go ahead and do that. Draw another member to here. Member. And I see now that I've drawn this member clear across the bottom and it couldn't be, so I'm going to click erase. Drag on the member that I want to erase. Click back on create. My members. So once you have all your members drawn, you'll want to add supports. So I'll click in one direction and drag down. Click in the other direction and drag to the left, and that'll give me a pinned connection. Click over here and drag down, that'll give me a roller connection. Last thing you do is have to add the load. So I'll click the direction that I want to be the load. In this case I want it to come straight down. Put in a magnitude, enter, and compute, and it will give you the information about the truss. And so you can see that these members are in compression, this one in the middle is in tension, these two at the bottom are in tension. And so that's how you create a truss design in MD Solids. Another thing to make sure you do is make sure your truss is statically determinate, or it won't be, you won't be able to solve it mathematically. Let's analyze this truss a little bit. If this is an example of a truss that you could design for your project, if we analyze this truss a little bit, we'll talk a little bit about the different things going on with it. I'll go ahead and compute. You can see that after I computed this, the biggest force that's going to be felt on this truss is a compression force at these members on the side. 66 or 67.6 magnitude force is going to be felt on that member. And so knowing the things we know about trusses is that trusses will always buckle under compression before they yield under tension. And so if I look at this truss right here, this is where this truss is going to fail. It's going to fail right here because that is the most amount of force that I can put on it, or that's on any member of this truss, and it's under compression. And so if I wanted to make this truss better and more efficient, I would figure out how to make these members either have a larger cross-sectional area by increasing the moment of inertia, or making them shorter in length. So that's two ways that I could handle that buckling that's going to occur on either this member or this member.